Also, we have a repository on which we will be working. This link will be available in the chat. We also have a drive link for the assets that we'll be using, including the backgrounds, the tiles, the player sprites. This link will also be available in the chat for you to download. Repeating once again, guys, for those of you who have joined, please download Godot engine by searching Godot on Google and visiting the first link there. Click on download and then download the version for your respective operating systems. Also, we also have a repository which we'll be using to build a project upon. So do visit that also. That links will be available in the chat. Please inform your friends to join fast. We'll be starting in a few minutes. यार चिल्ला क्यों रहे हो? Okay, guys, so now we'll begin. Sorry for the disturbance. So, as I mentioned, please download Godot engine by searching Godot on Google. And also, we are also having a repo on which we will start building. So, by the end of this lecture, we'll be having a game, Flappy Bird, which will look something like this. So, as you can see, we'll be having this game, and we will be building it from scratch. So now, let's begin. First of all, what you can do is if you have Git set up on your machine, you can just clone this repository uh, by copying this, opening the folder. By opening the folder where you have your Godot extracted, opening terminal there and writing git clone and the link. As a parallel, for those who don't have Git setup, they can go to the code and download this folder as a zip file. So now, let's begin with our lecture. So we'll be opening Godot and just scan for the uh, directory where you have your yeah, where you have extracted or cloned the repository. So just go to that folder and select. So we, as you see, we have a project here which is named Flap. Just double click on it to open. So first, talking about game dev. So what is game dev? As you have played many games, so we have different kinds of uh, methods in which we build games. Like we can build them on Java. We can build, as you play games on browser, they are built on JavaScript. We also build games on C++, but which will not be falling in this uh, lecture. lecture. We have various game engines such as Unity, Unreal Engine, Godot, and Blender, which was once a game engine. Now it's not as used as such. So in this lecture, we'll be using Godot. Godot is a very nice game engine for beginner levels, as it has a very minimal learning curve, and you can build nice looking games with this. So when you open Godot, it is this is the main screen that we are created with. So here we have the inspector, which will be containing all the properties of all the objects that we'll be adding in the game. This is our uh, directory folder of the game, which has all the assets. Uh, this is a uh, scene node, which where we can add nodes and objects, and those properties will be shown here. So we start by clicking on a 2D scene, as we are building a 2D game. So here you can see that we have an object node 2D. So first of all, what is a node 2D? A node 2D is a basic game object. Anything in Godot is a node. We add everything as a child of this node. So you will be greeted by this canvas. So first of all, we'll be building the player, like the bird which flaps. So right click on the node and add a child node. For a disclaimer, we don't expect you guys to follow along. as this will be a very basic lecture and recording will be available. So if you are stuck anywhere and resolving those issues will cost a lot of time and the lecture will go on for long. So you can of course follow along, but we don't expect you to follow along. So after at your pace after this lecture, you can see the recording and do the steps yourself. So beginning, we'll be adding a child node to the node 2D. So as we are building a player, so for a player, we have a special object known as Kinematic Body 2D. So what is a Kinematic Body 2D? In Godot, Kinematic Body 2D, as its name suggests, is for the player, and the user has the authority to control its movement. First of all, we'll double click on it, and rename this as player. So now we have a kinematic body 2D as a player, but we don't see anything because we have not added any image or something. So what we will do, we will add a child node to this, which is a sprite. So we have two options. Either we can add an animated sprite or a simple sprite. What is a sprite? A sprite is basically an image, or it is basically an image which will be displayed. So we'll for this we'll be making a animated bird. So we'll be adding an animated sprite. So after that, after we have added the animated sprite, click on here on the inspector window. We'll be selecting the frames that the bird will be animated. So click on new sprite frames and double click on the sprite frames. So we are greeted with this window where we'll be selecting the frames which we want to animate. So here you can see that it is blank. So you can see the second option in the nav bar. We can add frames from a sprite sheet. So we'll add frames on a sprite sheet, go into the assets, player. So we have three birds here. So you can experiment with what looks good. So we'll be going with the bird one. Here we can see that this is selected. Now we want to separate each of these components as a separate frame. But you can see that this is divided into 16 parts, but we want only 4. So here we can configure that how many parts we want. So horizontal we want 4, it's true. But on vertical we want only 1. Currently it is 4. So we'll just remove 4 and type 1. So now we have like a bird which is divided into 4 parts. So we'll just select all the frames and add. So now as we can see, the bird has been added, and we can see it in the canvas also. So now we can select the speed. For this tutorial we'll be using 12 fps. You can experiment with this and you can do any speeds here. So in the inspector node we'll tick on this on. So here we can see the bird has started animating. Do note that this is only an image. It has no like boundaries. So it is just a static image. But if we are playing a game, we want this to behave as a body, like which has boundaries. So when it will collide with the pipes, the game would be over. So here we'll be adding a collision shape. So what is a collision shape? As very evident by the name, a collision shape is a shape which can collide with other collision shapes. So basically, uh, uh, we'll be uh, we'll be adding a collision shape in the shape of rectangle around this bird. So click on the collision shape, and in the inspector window, click on shape and add a new rectangle shape. So as you can see, a collision shape has been added around the bird, but it is a little bit larger. So we'll click on rectangle and we'll resize it. So now here we have a bird which has a bound, uh, upper and like it has a upper and a lower bound, and right left also. So now what we will be doing, we'll be adding an area 2D. So what is an area 2D? An area 2D is a detection sphere. Like you will be passing through between the pipes, so it will increment the score. So it will be detected via the area 2D. So area 2D basically is an area which can detect like a body has been entered through or it is exit. So as a child of the area, we'll be adding another collision shape and repeating the same steps. But now what we will do is, rather than making it 8 pixels, we'll make it 8.5, slightly larger than the earlier one. This will help us detecting the collisions very more precise. So we'll be renaming this as detector, and we'll save this. So we'll save this as a player. Click on save. So here you can see in the directory we have a player C. Uh, so you can double click on it and it will open up. So next up we'll be adding some code to this player. So like we have to add movements that the bird will go up and down, etc., etc. So just click on the player here and click on this. So it will be creating a script. So we'll be writing some code here. So we'll be writing this in GD script. Do note that GD script is very similar to Python. For those who have used Python, it would be very easy. For those who don't, you must be you must have learned like C++ or something. So it's not a very big deal. You will be able to understand what's happening. So first up, what we will do, we'll be adding a button control. So go on to the project settings, input map, and we'll be adding an input flap, which will basically will press space so the bird goes up. So we'll be clicking on add. So you see a new action is added here. So in this action, we'll bind a key to it so that every time we press that key, this action is called. So we'll add a key, physical key, and press space. So here you can see space has been confirmed. So press OK, and the space is now bound to flap action. So for the code, I'll be using the code here because writing all the code will make this lecture very long. But don't worry, I'll explain you code line by line. So first up, we'll be using these variables. So first thing, this is a so first variable is gravity. So as you can see, let me show you in this game. As you can see, this bird is moving, but also it is moving downwards. Like if you leave the space, it will go down. So this means this scene is having some gravity, which is pulling the bird down. Also, this bird is when we press space, this bird goes up. So it is having an upward velocity when we press the space. So we'll add these things here. So first variable is gravity. Second variable is up. I'll tell you what this up means in a little bit. Uh, we have another variable flap, which basically gives the upward speed. Like when we press space, this will be the upward speed of the bird. And we also have a max fall speed, so that the bird, when it accelerates, it does not cross this speed. Like if the gravity is there, so the physics engine does not know that it has some terminal velocity or something. So we have to give it a maximum speed so that it does not cross this speed. Otherwise, the bird will fall very fast. So on another variable, we have a motion, which is a vector 2. Vector 2 basically is a uh, like is a vector type of variable which has two components, x and y. So we'll be using this motion variable for movement of the bird. So it is having like we can specify it as 2 comma 1. So it has a vector which is extends 2 on the x-axis and 1 on the y-axis. So we'll be using this for defining the motion of the bird. Another one, we have variable score, which is evident that it will increment the score as the bird moves up. So first thing, we'll delete all this crap which is there and just remove this. The first function we are greeted with is ready. So this is a inbuilt function. It is called whenever we play the scene. So it is once it's like a constructor if you're familiar with that word. So it is called once when the scene is being loaded into the game. So in the ready state, we will be declaring these variables. So we will be initializing these variables. So like gravity will be keeping at 10, flap at 200. So that is we have declared above also. Just move from there, and score is 0 in the initial. So next function we will be writing is physics process delta. So this is physics. What is this is also an inbuilt function which is called on every frame. Like this function is called on every frame when the game is being played. So we'll write all our game logic like where the bird will move and when it will move in this function. So in the physics process, I will be writing this. I'll be writing this code. So sorry. So right now this function has not been declared. So let's just comment it out. So here, let me explain you this code. So whenever so like when we are playing the game, if the bird goes below the x-axis, the game is over. So that's what we are checking here. If the position of y is less than minus 160, so we are at the center. So the coordinates are minus 160 and plus 160. The center is here. So we'll be checking that if the position goes below 160, we'll be calling the dead function, like the game reset, and basically the game has been over. And also, if the bird crosses the above bounds, which is plus 160, so game then is also over. So the next line is that remember that I told you this function is called on every frame. So in every frame, the the motion dot y means the motion was the velocity of the bird. So its y component is incremented by the amount of gravity. So it is accelerating downwards. So like in every frame, the velocity, the y component of the velocity is incremented by the gravity. So like the birds accelerated downwards. But I told you that we have to have a check that the maximum speed does not cross 200. So if the velocity crosses 200 max fall speed, which is actually 200, it will be it will be equal to 200. So that never ever it crosses 200. Okay. So now the next line is that remember uh, we did a key mapping to the action flap. So here, if the input dot is action press, this means that if the flap action has been called, then what will happen? So what will happen here is the y component of the velocity becomes minus flap. So basically, this is the minus y-axis and this is the plus y-axis. So we're giving it a velocity of minus flap, which is minus 200. So whenever we press flap, the bird has a upward velocity of 200. So like this, and gravity is acting upon. So in the next frame, the bird again comes down. Do you understand? So let me explain it again. Whenever we press up, uh, the bird has now an upward velocity of minus 200. So the bird goes up. But now we are gravity has been acted upon. So the bird again comes down. So this will be creating a game that effect. Then we press flap, the bird will go up. And this basically uh, is like will be this is a function which is provided by the kinematic body 2D. So basically it tells the body to move in motion and up direction gives it like to come down after like to act upon the gravity also. So move and slide you have to call. If you don't call this, the body will not move. So move and slide basically is a function of kinematic body 2D, which is our player. So it will instruct the body to move. So now let's save this and we'll try to play it by here. So you can see the bird is here, like because we haven't set up any camera or so. So you can see the bird is at the corner, but as I'm pressing space, the bird is going up and so. So next we'll be creating a new scene. So we have a bird. Now we need the pipes through which the bird will pass. So we'll again create a node. We'll be renaming this as wall node. As a child of this node, I'll be adding a sprite. So uh, we'll be adding a simple sprite because the tiles are like not animated, they are static. So for this, go into assets and tiles, and we have a tiles.png. Just drag and drop it to the texture. So now you can see that we have a tile imported here. So now it is in the center. So now we have to make it. So bird will be here in the starting. So we have to give it a give it an like an offset so that it comes below the x-axis. So what we will be doing here is uh, so we have to make it come down on the y-axis. So we'll be giving an offset of 140 pixels. So here you can see that the pipe comes up. So we have the down pipe and now we need the up pipe. So we'll again be adding a sprite and again we'll be using the same image. So now it is in the center, but as an offset we'll be giving it minus 140. So it moves up because I told you that this is a little bit different. This is the minus y-axis and this is the plus y-axis. Similarly, this is the minus x-axis and this is the plus x-axis. And so we can see that the pipe is now not oriented correctly. So what we will do is we will flip it vertically. So now you can see we have a pipe structure. So bird will pass through in between. So next we need is that we want to detect that the bird is either it is going between these pipes or it is colliding with these pipes. So remember I uh, told you that we added a collision shape to the bird. We'll be adding a similar collision shape to these pipes as well. So we'll be adding a child node which is a collision. Okay, so I have made a mistake. Sorry for that. As a child of the wall node, we have to make it a static body 2D. Sorry for that. So static body 2D will be the first child of the wall node, and these sprites will be the child of static body 2D. So what is static body 2D? As like the kinematic body 2D, which is controlled by the user, static body 2D is, as its name suggests, is static, which user has no control over it. It is basically used for these background elements only. So we'll be renaming this as wall. So now we have two sprites here, and as a child of this wall, we'll be adding those collision shapes. So as this collision shape, we'll be adding a new rectangle. This will be 60 to scale it in the x-axis and 100 to scale it in the y-axis. Remember that when I am saying that scale 100 in the y-axis, so it is 100 upward and 100 downward. So basically this has a dimension of 200 by 32 because we have x as 16, so x 16 here and 16 here. So now we have to align this with the bottom pipe. So what we'll be doing the same position and we'll give it here minus 140. So okay, so minus will do. So if we'll do plus, it will go down. So here you can see that collision body is perfectly aligned with the pipe. So whenever the bird collides with this body, we'll get to know. Similarly, now we'll duplicate this. So here I have duplicated this, and in this I'll be giving the coordinates -140. So now it is aligned with the upper pipe. So we have a collision shape. Whenever a body collides with these two, we'll get to. So now the next thing what we need is that we want to detect that whether the bird pass through the middle of the pipes. So we'll be using a similar collision body here also, but will not end the game in that if the bird collide with that body, we'll just increment the score. So we'll be adding an area 2D as a child node of wall, and as its child node, we'll be adding a collision shape, a rectangle, and because it is -140 and 40, so the width which is remaining is 80. Oh, sorry, 80 will be using 40 so that it is scale. So here we have now uh, a body, a collision shape here also, which will detect whether the bird is passing between the pipes, and the score will be incremented whenever the bird passes through this. So now we will be saving this as wall node. So now we have a completed wall. So don't worry, we'll be generating these walls as the bird goes on. So we don't have to create separate walls for every scene. Just a single wall will do, and it will be generated as the bird moves along. So now we'll be setting up the main scene in which the game will be played. So now we'll be adding a new scene, a node, and we'll be renaming it as world. Uh, so this world scene, we'll be setting up the bird and the pipes together. So click on the world scene. So now we want to import the player in the world scene. So here we have a link. So link it and add the player to it. So now we have a player here. So we'll just rename this as player node. So we have the player node here. But what we want to do is we want to completely control the player here. So just right click on this and click on make local. So now the player is locally imported here, and we can make all the changes that we want. Okay, so now we go on to save this scene. So now we go on to the wall node, and we want to add a script here. Onto the wall node, click on new script, wall.gd, and create. So what we will be doing here is that, let me explain. So like this is the game. So basically what is happening is that bird is not moving forward. The bird is in its place, just moving up and down. The walls are moving in the minus x axis. So here you are getting the illusion that the bird is moving, but not. The wall is moving in the minus x axis and the bird is static at the place. So what we will do here, is we'll be adding physics process function. So basically we want to move the wall in the negative x axis. So we'll be using position equals to position plus equals. So for those who coming from a C++ background, this plus equals is generally means position equals position plus some x. Like x is nothing, just I am giving an example. So you can reduce this statement position equals to position plus x by using position plus equals x. So these two statements just mean the same. So as a position is having two coordinates x and y, so it will be a vector 2, and we want to move it in the minus x axis. So we'll be adding -2 comma c. So the wall will be moving with a speed of -2 pixels per frame in the minus x-axis. And now we'll save this script. Going on to the world scene. Now we want our walls imported into this world. So just click again, link the wall and open. So we don't want to control this wall, so we don't have a need to make this wall local. So currently this wall is in the center and the player is also in the center. So we have to move it along the x-axis. So first we will be adding 5 wall nodes here. Just click on the wall node and press Ctrl D 5 times. So we have 5 walls which will be which will be serving as a start screen, and after that the walls will be generated as the bird goes along. So click on the first wall node, transform, and we will be giving it an initial position of 300 pixels on the x-axis. So the wall is at 300 pixels and a y-axis position also, because we want the walls to be at a randomly placed, like some are high, some are low. So we'll be give it a y offset of 30. So it moves down. Now similarly click on the wall to transform. So we'll be placing the walls at a distance of 150 pixels. So earlier it was 300. So now we want to place it 150 pixels after 300. So we'll be getting it 450. So here we have another wall. So to give it a random, we'll be using, like, you can give any random value here. So now just let me just do it quickly. So now we have our 4 walls placed as. So now we'll just press Ctrl S to save this. So next up, remember that when we played the player scene, the bird was in the corner here. So we want our viewer to view as we expect it to be viewed. So what we will be adding now is a child node. So we'll be adding a camera as a child to the world. So we'll be adding a camera 2D. So here you can see we have selected the camera. So here is the camera. You can see the boundaries, but we don't want the camera to be so big. We'll just zoom in a little bit. So zooming in means you have to reduce the zoom parameters. So we'll be using 0.5 here to just zoom in 2x. So now we have a camera. You can see this is the camera. This will be our main screen, which we want the user to view. So click on current and save. Now if we play, so now you can see that we have a basic draft ready, where the bird, like, it collides, but we don't have any function here yet ready, so that the game will be over. So here you can see that we have created a basic C. So next up, what we will be doing is we will be generating the walls as the bird moves along. So as a child to the player node. So basically, let me just tell you first that what will happen when the bird moves along. So first, add a child node to the player, which is also an area 2D. We'll be naming it as a resetter. And as a child, we'll be adding a collisions chain. So we'll be scaling this rectangle. Don't worry, I'll tell you what I'm doing. Just be with me for a bit. So it's okay, and we'll scale it to 150 here. So we can see that this is a shape. We want this resetter to be out of the camera. So for this transform, we'll be giving it a position of -280. So just this resetter is just out of the camera. So what will happen is this resetter will move along with the camera. So we will write a function, then whenever this resetter hits a wall, this wall is deleted and another wall is generated above that. So it is very important that we also delete the walls as they are going, because they will be in the memory, and that will create a RAM hogging issue and make the computer to slow down. So we have to do that whenever this resetter hits the wall, because the walls are moving like in the minus x-axis. So whenever the resetter will hit a wall, this wall will be deleted and a new wall will be generated in the front of the last wall. So we'll be writing a code to do this. Just save the scene. So now what we will be doing is that click on resetter, go on to the node, and here are some signals. Like we want that whenever this hits this, then we want to have a function call. So this is a signal. So just click on resetter, click on nodes, and search for body entered. So we'll be adding a signal that on resetter, whenever a body is entered, so we'll be connecting it. So here you can see that we have a new function and on resetter body entered. So whenever a body is entered in the wall, on the resetter, whenever a body, like it could be any body, not just the wall, so that function will be called. But we will configure it so that whenever it hits a wall, then only the function is executed. So remember, a wall node has the name wall. So what we will be checking here is that if body dot name is equals to wall, we want to delete that wall. So for deleting, we have a function q free. So we will be calling body dot q. So the body will be deleted. Now we want a function that whenever a body is deleted, a new wall is also generated. So what we will be doing here, we will be importing a wall node by using where wall node equals to. So if we want to load a scene in a different scene, so we use a preload function, and we will specify the path of wall node here. So we'll copy path and paste it here. So now the wall node has this wall scene. So now we will be writing a function. This will be our own function, wall reset. So whenever a wall reset is called, we want that a new wall is generated. So to create a new wall, we will be using var wall equals to wall node dot instance. So basically what it does is it creates a copy of this wall node. So every time this function is called, a copy of wall node will be created and stored in the wall variable. Now we want to place it, we want to also to position it. So what we will be using it, wall dot position equals to vector2. So now we want to position it. So we will be positioning it at 500 pixels on the x-axis. Like you can put any value there, but I'll be using 500 because it gives a more equally placed wall. It shows like equally placed wall, and we also want that the wall is displayed on the y-axis to create that randomness. So we'll be using randRange function, and which will vary from -60 to 60. So what it will do, it will pick up a random number in this range, and the wall will be placed uh, at that same position. Okay, so we will be calling this function here, wall reset. So whenever a wall is deleted, the wall reset will be called and a new wall will be generated. So let's just check if I have written right. Okay, so one function is remaining. So what we want to do is we want to add this wall here in this scene. So currently we are on the player.gd script. The player is here. Okay. So what we will be calling a function. I will explain it to you. so don't worry what I am writing. So basically what is happening? So currently you can see that we are on the player.gd script. This script is connected to the player node. So basically the player node is a child of the world node. So what we will do is we will call get parent. So we are currently on the parent player node. So when we call get parent, we go on to the parent of that particular node. So in this case, we call get parent. So we are on the world node. So get parent dot call default. This function is used when you want to call a function of an another node. So basically we are in the player node, but we want to call a function in the world node that it should add a wall as its child. So basically we'll be using call default add child, which is an inbuilt function of any node. You can use it with any node and wall. So basically it will do is it will call the add child function from the world node. So we are done here. So let's play. Let's check if that walls are generated. So basically you can see that the walls are now generated. We had initially placed only 5 walls. Now the walls are generated. So, as the wall goes out of this camera scene, it is deleted and a new wall is placed on the 500 pixel. So as we see, the basic game is ready. So next up, what we want is uh, we want that the score to be incremented, and also whenever the bird collides, the game is reset. So again, we'll go to the world node, player node, and as we had done with the resetter, we'll do it with the detector also. So detector will be adding body entered and connected to the player. So whenever a body enters the detector, in this case we will be checking that if see detector is this outer square which is surrounding the world. So we will check if this body enters, this region, then the score will be incremented, and if this body enters then if this body enters this, then the game will be reset. So what we will do is go to here, and I have currently not written the function to increment the score, which will be written uh, afterwards. So I'll just tell you guys how to add a like this signal, and just do so if the on detector body entered. So we'll again check if body dot name equal wall. So if the body which is entered in the detector is wall, so basically here we will call game over. This function is not currently written, so I am not like writing a function. This is only a placeholder. So this function will write afterwards that game over function and replace this line with that function. Similarly, this is for the collision, and now we want that the score also to be incremented. So similarly, we'll also add a node, but remember that this was an area, so we cannot use that on body entered. We have to use on area entered. So we'll search for the function on area. Oh, sorry, area entered and connect. So on detector area entered. So what we will be doing here is increment the score. So score here will be +1. That is also a separate function. So I am leaving it just for now. We'll replace it when we write that score incrementation function. So that's it from my side. And now my friend Pragyansh will continue the lecture further.
Okay, guys, is the screen visible? And am I audible? Okay, then. So the first part, the gameplay part, which was done by Mayank. So he has pushed these changes to the. He has created two branches, one main and one final, in his repository, and I would be pulling these changes from the final branch, the latest changes which he had done on stream in front of you all. So these are the changes. You can see he created some scenes like wall node, player, and he wrote some GD scripts like wall, player, and yep. So that's about it. So I observed that many of you have not got Git installed, so that's fine. It's no problem. That just makes it a bit. You won't be able to use Git from your command line then, but you can always download the code. And how can you download it? Press this drop down code, and you have this download zip. So you can download all the whole repository as a zip file, and then unzip it, and then change it as you like. So that's about it. So let me first fetch the changes he has done. So mm, So right now I did a fetch, which fetches all the new branches which have been created at the remote. So remote is that GitHub hosting, and then I checked out to a new branch, not a new branch, like a branch which has been created on the remote. Checkout is for changing your Git branches, and then I tried to pull all the changes, but it turns out that I've already pulled whatever was there. So let me check the file directory once. GGJ demo, flap flap. Yes, I have player.tscn and walnut. So I have all the changes which Mayank had done. So this is about it. Now let me open a new Godot instance. And I'll be importing GGJ demo, flap flap project.go.open, import and edit. And here you can see that I have got his uh, changes done here. So we'll just play it once to check if it works as it should, as it did in his stream. Yes, I guess the procedural generation is working fine. So, what is procedural generation? Just the thing like removing existing redundant blocks from memory and adding new ones at the start of the world. So, what he was doing was removing pipes at the end and adding them at the front of the level. So, he basically wrote a very simple procedural generation algorithm for this. Um, that's it. Huh, we are good to go now. So what I will be doing is adding UI to the game, adding scoring, death, high score feature, music, and making the games a bit more spicy. Like we have no backgrounds, we have minimal artwork. So let's work on spicing this game up. And in the end, I would suggest some more edits you people can do. Like we will deliberately miss out on some features to make the session smaller, and for you to give you space to work on this project. And we'll also be telling some of the deliberate mistakes we did, and we'll tell possible solutions for them, so that you can have good development practices and code writing practices. So first of all, I would create a new scene. the start screen, because this is the gameplay screen. We'll have two scenes in this game. The first one would be the start screen, where we will have a mute and unmute button for music, and we will have an information button which will tell you the high score, and will give you the credits, like who made the games, who made the assets, where we take the music from. And there would be a simple play button, and it should look good. Like, it should have a moving background, it should have the animated bird sprite on it. So we'll try to make it look good. So okay, so I'll first make a new scene. So we have a new scene, the empty scene. Let's name it something. Before naming, let's add a 2D node to it. So I think Mayank has told you all what a node is. A node is the most basic component you can have in Godot. Everything in Godot is a node. Every entity in the game is a node, and it the node can have different properties. But selecting a node 2D, the most basic node without a lot of properties, is what we do for the root node of any scene. Root node of any scene is the ultimate parent, ultimate ancestor of every node in the scene, because every entity in the scene is a child of some other entity except the root node. So let me make the root node. So we have node 2D, the root node here. Let me save this as start. So this is our start screen, the start of our start screen. And let me show you how this would look like at the end. So we have the end of start screen ready here. So this would be a node, there is some background to it, then there are a couple of buttons, and then you can see this overlay which tells you the high score and the credits. And let me show you how it would look like in the end. So as you saw, we had a scrolling background, we had a moving animated sprite bird. I'll tell you what animated sprite is in a moment. And we had some background music to it, and that background music was Death by Glamour, which is a soundtrack from Undertale. If you would have heard of this game, Undertale is a very famous game, made by Toby Fox. He is an indie game developer, and I like Undertale personally, and I like its soundtrack too. Like, it has quite a peppy music. So we'll be using two tracks from Undertale, Death by Glamour and Megalovania. Megalovania is the final boss music. This was just some trivia about Undertale. So here we have the mute button, mute and unmute, and we have this information button which will tell us our high score and the credits. Like, you can see our names and whom we took the music from, and where we took our assets mainly from. And this is a toggle button. So like, you might have seen buttons. So buttons in Godot are simple buttons in Godot are like keyboard keys. You press them, and they will depress, and then they will do some action. But toggle buttons would act like switches. They would have two states, like it has a depressed state right now, and then an expanded state. So that's how it will work. So this is what our start screen will look like. So let's get to work now. So first of all, in this project, we will add some background to it. And for background, we'll be using Parallax, which is a clever trick. I will show you how it works. But first of all, I will load the nodes. So let me add a child node first, which would be Parallax Background. I will tell you what these nodes are in a minute. So just keep following what I'm doing. You don't need to replicate my steps. I will add a parallax layer to it, and then I'm adding a sprite to it. A sprite is a basic texture displaying node. It's very basic. So in sprite, I will load a texture. We shared an asset folder with you all. I shared a Google Drive link. It's on our Discord's announcement channel, and we shared it on the Twitch chat too. But there has been a lot of spam on there, so you can get it from our Discord's announcements channel. There's a Google Drive link where you will get our assets folder. So in assets, I will use demo image 1.png as our start screen background. So it has spawned here, but we see the viewport is underlined in this blue color rectangle, and if we play it right now, play the scene right now, it will only show us 1/4 of the png. So we have to scale it to fit into our viewport, and then we have to change the positions of it. Oh, and yes, what's a viewport? The viewport is the part which we're seeing on the screen, the gray background part, where we do changes to our scene which can be reflected on the viewport, and then there's this camera outline on it which will show how our window will look on the debug mode. Like whenever I click this, I enter the debug mode of my game. This is the debug mode. You can see debug. So let me reposition my sprite a bit. In fact, the whole parallax background a bit. So we'll go to transform. Transform is basically the position and scale and rotation of any body. That's called the transform, because it uses transform matrices in the engine to change the position and rotation of things. So since we have a 1024 x, so I'll be changing it to 512. Let me see. Oh no, scaling. 1. So instead, if I change the sprite, I'll be changing the sprite position. Okay. So let me enter 512. Yes. So 512 gives us to brings us to the center of the screen because I have a 1024x viewport. And for y, I guess it has to be something like 300. Let me check what the exact value I used in that game. Sprite has 512 and 300. Yes, it's correct. And the scale has to be 2.3 and 2.4 so that it fits our viewport. So let me just change the scale. You can find it out using basic math, like how many pixels your screen is and how many pixels the image is, and what should be the scaling factor which you need so that the viewport can be filled by the image. So I will scale it just by this. So right, we have a basic background ready, but if we will play it, it's not moving, it's static. While in that in the final game we want it moving. You can see it, the background's moving, and the sound's not playing because it's muted. If I unmute it, it'll play again. Yeah. So we need a moving background. How can we achieve this? We can achieve this using a parallax background. Now, what is parallax? Parallax is a technique in 2D game development where we have many layers to a background, and we can give each layer a different velocity at which it will loop itself. Like a frame, there are multiple frames, and each frame moves forward, and then after it creates overlaps, or it might have two pictures side by side, and after one of them moves out of the viewport, it again regenerates at the back end. It is just like what we were doing with walls, but this is an inbuilt feature of the Godot game engine, so we'll be using it. And to give more context, I have a GIF from Mario 3. So in this you can see three different layers moving at different velocities. The front clouds you can see, which are in that white color. Then we have these wooden blocks, and at the background we have those dark clouds. You can see these three layers are moving at three different velocities, which give us a perspective, a depth perspective in 2D games. So bringing a depth perspective in 2D games is difficult because depth is something we relate with 3D, and this is 2D rendering. But if we give different velocities to different layers, then we can create an effect. This it makes it look like the blocks are in front of those dark clouds and the white clouds are in front of the blocks. So these different velocities give us a depth perspective to the game. But for our game, we don't have different layers, we have only one layer which we need to loop. So yes, we'll be using this one layer, we'll be imparting it some velocity, and we'll get done with this. So we'll be adding a script to our parallax layer. I'll show you what the script will look like. This is a small script. I'll just stick it there and we'll explain to you what this script does. So parallax background, let's add a script to it and we'll name it what? BG scroll, background scroll. So let's create it and remove everything, paste it here. Now what it does is function process delta. Now what is the process function? The process function is something which is called every frame of the game. You know there are many frames being rendered every second in a video or in any animation format, and video games are no different. So the process function contains code which will run at every frame render. And what is delta? What is this attribute delta being passed to a process function? Delta is the time in which it takes to switch between frames. So effectively what we are doing is scroll offset dot x should be lessened by speed into delta. Speed is an export variable here. Now what are export variables? In Godot script, GD script, you declare variables by using var or const. Okay, but when we add export var to a script, what happens is when you go to parallax background now, you will see script variables where you can see a speed variable which you can change from the engine itself, from the inspector itself. This column here is called the inspector. It shows us the properties of an entity, of a node. So you can change it from the engine itself. Now if I declare any other variable like var dummy is equal to 10 and I save it again, you can't see it here. You can't see it in script variables. But if I export it, see, a dummy variable has come up here. So export allows you to change the variable values from the editor itself without doing changes in the script. So because we would make this code public to you all and we'll allow you to make changes to our code, our game. So we created speed as an export variable because that is something you would like to change from the editor itself. You won't like to dig into the code and do some changes for that. Okay, so what is scroll offset dot x? Scroll offset is just the uh, position that a parallax layer should have at any different at any frame. And what is dot x? X is the x coordinate of that scroll offset, and what we are doing is decrementing it by speed into delta. Now speed into delta just means that in 1 second the background will scroll by 400 units. So that's basic 2D geometry maths. So every one of you might know it. And this we'll worry about this a bit later. Let me just comment this out. We don't need to worry about on texture button pressed right now. I'll comment it out. We have turned these into comments. Now if I'll run the wait a minute, one more thing, we have to the the background in the parallax layer. So how we have done it in the final game parallax layer, we mirrored it by our screen size, our screen x. So we will just mirror it by 1024 so that we can have two different backgrounds which will scroll with each other, and when this one completes it will be transported at the back of the second one, so it gives an infinite scrolling effect. Now let's go, let's see how this looks. And see, we have an infinite scrolling effect, which kind of looks good. So we'll be using it as our background. I think this part is done. Now we'll add an animated sprite. Now, what is a sprite? I've told you a sprite. We have used a sprite here. Sprite is something which shows a texture, and here, in our case, the texture was our demo img1.png, which was a PNG picture file as a texture. But what are animated textures? Animated textures are textures which use multiple textures and show them one after the other and create an effect of animation. We can define the FPS at which they work and other things. We used Mayank used animated FPS to make the bird, and we'll do the same thing. I'll explain how it works. So animated texture would be a child of our root node 2D. Let me add a animated sprite. Yes, we have got an animated sprite, and it shows a warning. A sprite frames resource must be created. Okay, so I'll create it, don't worry. So yeah, frames. So I need to give it some frames to work on so that it can set FPS, at how many FPS that sprite has to run and other things. So uh, I'll do a new sprite frames because I have not created any sprite frames object in my assets, but I have a sprite sheet to create a sprite frames object. Now, what is a sprite sheet? Let me show you. Assets, player, bird1. We'll be using bird1, I guess. Mayank used the same. Yes, bird1. So you can see there are 4 frames here, 4 frames of the bird. So what we'll do is slice these 4 frames and use these 4 frames again and again on top of each other to give a flying animation to the bird. So let's do it. Now this slicing feature, if you'd be making a game with C++ or JavaScript, you would have to write it yourself. But many game engines support this sprite sheet slicing feature, and Godot also has it. Many prominent game engines have it. So it's a fairly universal feature. So let me edit the sprite frame. I'll give it a resource. Okay, where did I do it there? Animated sprite. Yep, I created a new sprite frame. Yes. Huh. So okay, these are the sprite. This is the sprite frame stock. I was looking at the wrong place. This lower part is the sprite frame stock. So what I will do is import my player bird1.png. Open it. And nope. New animation. Default. Delete it. This is not how we want it. Add frames from a sprite sheet. We don't want to add frame just like this. We'll add it from a sprite sheet. Delete this one too. Add it from a sprite sheet because I told you what sprite sheets are. So player bird1. So yes, we have the sprite sheet mode open now. Now this is something Mayank would have done also. There are 16 frames, but we want only 4 horizontal ones, and if we have only one vertical one, so we'll have these 4 different sprites at any which would be sliced by Godot. So yep, select all frames. Select every frame, add 4 frames. Yes, we have it. And yep, and then we go to our animated sprite. Playing on. Where is our animated sprite? Let me bring it to the center using transform 512, and y should be 300. I think it's pretty small, so we are not able to see it. Or is it visible? Check there. We gave it a scale of 3 and 3. So yes, it's pretty small, and that's why we are not able to see it. Still not able to see it. Okay, let me bring it to 900 first. Can we see it there? No, there's something wrong. Wait. Animation should be default. Yes. Okay. I had created a new animation which was not deleted. So when I chose animation default, it showed up. So yeah, 300. And now we have a moving bird at the center of our start screen, but it's moving very slow because it's moving at 5 fps. Let's increase the fps to something like 12. Yes, now I think it's an acceptable speed. So if we start the screen now, start the scene now, we have a scrolling background and a flying bird. So yes, it looks good. Uh, and now what should we do? I think our start screen needs a title now. So let me just hide this. Okay, so we had this title flap flap. Now it uses a font which we have in our assets. It's called Caveman True Type font. We'll be using it, and then we added some colors to it. I'll be doing it. So we can see the scene tree here first of the label. Mm, hmm. So yes, I have added two labels to the node, its root node itself. I think we can do that, but the right way is to add a node then to the root node and then have two children of its label. But I think it's a small project. It's possible to have two labels directly connected to the nodes. Let's not worry too much about it and add it. Label. We'll name it flap. And yes, how to add font in Godot? In Godot, you add font using this theme option in control. But before adding font, we'll add the position, like because see, it's getting generated at 0.0, 0 comma 0, and we want it to be at some other position. So what position is it in our final game? It is at 337 and 25, and I did the 337 because the size is 349, and what I must have done is 349 by 2, 512 minus 349 by 2, which would have approximately given me 337. And yes, that's how I must have written it. So you can do, these are basic calculations which can be done easily. I'm not worrying about it right now. And why was 25? Because I did a fair bit of trial and error, like where should I fit it, and it was looking good at y is equal to 25. So now let me add the font. We'll add a new theme and we'll give it a new dynamic font, and the dynamic font would have a font of, now dynamic font is a font data which Godot can parse. We have to give it a true type font ourselves. So I'll load a font. Oh shit. Load a font assets. I think it's in extras. Yes, I'll be using caveman.ttf first. Open. Yep, showing it correctly. Now what was the size? It was 49. What was the size here? 122. 122, 122, 122. Let me check. It must have been 122 then. No, I don't think. Let me check what size that was, because size was 100, not 122. Now it looks good. Extra spacing not needed. Resources not needed. Okay, not needed. Outline color not needed. Not needed. Okay, we are done with the font part. Changing the color has to be by theme overrides, I guess. Yes, we have this colors. So adding the font color, I think it has to be a shade of red, as in there. We'll do with it. So this is flap. Now we'll create a second one. Just copy it and paste it as a child of node 2D, label 2. It has the same thing. It will just have a different y coordinate, I think 50 or something. Let's see how 50 looks. Bad. 150, bad. 120, Passable. Let's have it 100. Good. We'll give it a different color. Hmm. Something like purplish. Yep, makes it. So I think that does not look too good, but it's passable. Flap flap. The title is okay. So we have done the title part. Now we'll add a mute button and some music to our game. So let's add a node because let's see the scene tree how we did it in that game. We have a Node 2D to which we added a texture button and an audio stream player. Now I'll explain what these things are. Node 2D is, I know you people know now what a Node 2D is. We have Node 2D, we have a texture button, and then we have an audio stream player. Now there are three types of audio players in Godot. Audio stream players are just audio playing nodes. So there's a basic audio stream player, then there's audio stream player 2D, which plays audio in spatial 2D. So if you will be at the right end of an audio stream player 2D node, you'll hear the sound coming from the left ear, and if you are at the left side of an audio stream player 2D node, you'll get coming from the right ear. And you know what 3D, I hope you know what 3D spatial sound is, and that's what is achieved by using an audio stream player 3D node. So we'll be using a basic audio stream player node. We don't want spatial effects. Oh no, we'll reparent it because I want it as a child of node 2D, not a texture button. Reparent it to node 2D. Reparent. Okay, now we have a texture button. Now there's a simple button in Godot, then there's a texture button. How is a texture button different from a simple button? A texture button allows you to have a texture on it. So that's pretty basic, I guess. Now I'll add the textures. So the normal texture should be loaded. Assets, not the player. Extras, I guess. Unmuted.png is normal, and I guess it's very big. Now I will have to change the scale. Let's make it a tenth of its original size. No, it still doesn't work. A 20th? Still it's too big. What I did in the original one, let me check. What scale did I use here? 0.35. That's pretty small. So I've scaled it down pretty much by a lot. Okay. I'll place it somewhere at the bottom left. So, yep, 500. Give it some amount of X. That looks good. So this would be in the normal position, and because it's a toggleable button, I mentioned this at the start that the mute button is a toggleable button. So we'll have the toggle mode on, and the pressed one would be our muted.png, which you might have. Oh, what happened? Muted.png, which you might have seen. Extras. Muted.png. So let's play this once. If the toggle works correctly, so you can see the toggle feature is working correctly. Now we'll add some script to this, and no, first of all we should add some music. So I have two audio pieces, Death by Glamour and Megalovania. Let me open Death by Glamour. Playing. You might be hearing Death by Glamour being played. So we'll set autoplay on, and when we will start the scene. Okay, but right now we have not connected the mute button to our audio stream, so it's not getting muted. So we'll do that using a script to the node 2D. Now let me open that script. We'll be copying that same code, and I'll be explaining what happens in that script. Okay. Okay. Hmm. Add script muting.gd. Hmm. Hmm. Okay, now it will show up some errors like what's game state. By this point, I should introduce to what a game state is. So game state is something which will preserve the state of a game, like if it has entered the gameplay mode, what the high score is, and such things, and saving of data, like we need the high score to persist, we need the state of mute button to persist, and this is something we'll be saving. So we have these functions save game and things too. So I'll be making a game state which is basically a singleton. A singleton is something which can be accessed by every node in Godot. So I'll be making a singleton. Project settings, auto load, and no, first I have to create a script. To create a script, file, new script. Let's call it game state. The class name would be game state. No class name. Okay, create. Yep. Now I will open the auto load settings. Game state.gd. Huh. The node name is game state. We'll add it to the singleton. Yep, added. Now we have some things here. Let's delete them. Now what you'll see is that in muting.gd we have something like load game and game state.music. So first of all, what I'll do is comment load game and save game for now, because that is something we will be dwelling on later. This is basically saving of games that I'll explain later. Before that, I will create a boolean in gamestate.gd var music. It will say whether the music has been turned on or off via the save button, music button. So yes, and in muting.gd we have if gamestate.music, we have a negation here, then gamestate.music. Like if gamestate.music is equal to false, audio stream, first of all, when the ready function is called, like when the scene is started, audio stream player will start playing the music, but then it will go and check the gamestate.music boolean from gamestate.gd. If gamestate.music is false, it will change the stream paused attribute of audio stream player. What is stream paused? What stream paused is, it just tells us whether the stream is paused or not. So basically it will invert stream paused. First it was playing on line number 5, so on line number 7, if gamestate.music is false, it will get paused, and once it paused, it will change gamestate.music to stream gamestate.music to whatever the stream paused, however the stream's current state is. If it's paused, it will change music to false, else it will change it to true, whatever it is. And if gamestate.music has been false, we want the texture which has to be loaded on start to be the muted one. We don't want the music is like the music is muted, but the texture of that button is showing that the music is unmuted. If we don't add these lines here, what will happen is, you'll see in a minute. Okay, let me just play it once. I think it should work. Yes, it's working. So right now the music is playing. I have not added the feature to it. And if I set the gamestate.gd music to false, the music won't play, but the texture would be that the music is playing. So let me just check. Okay, the music is not playing, but see the texture. it shows that the music is playing. We can avoid this by interchanging the textures of the normal and toggled mode. So if now we do start it again. What happened? What happened? What happened? Okay, this is a texture button, not texture button dot two, texture button two. So we just changing the variables a bit. There was a typo in the code. Start it again. Now you. What happened? The path is wrong. The path is wrong. So assets, extras, extras. I guess muted.png is in extras. Let me check. Yes, muted.png is in there. There. Wait. Hmm. So something similar should be done here. I did a typo in the path too, because I'm doing is copying that code, which is a bit different from mine. So I would have to do these changes because I've changed the asset structure. Now it should work. Let's see. So yes, the game music is not playing and it shows the muted texture instead of the start texture. Now if I go to game state and change it again to true, go. It's showing the playing one. Now what I'll do is uh, change the audio stream in such a way, connect the texture button to the audio stream. So let me open it again and see. So we come upon the subject of signals. Signals is something that a node will emit, like we can specify it in the code, or there is some functionality that Godot provides for a signal emission and signal detection. So what happens is, in a scene, if a node emits a signal, every other node can hear the signal, and there would be some node which we would have connected the signal to, and if it receives that signal, it will act upon that signal. So this is like someone shouting that he has done some work, and because that work's done, some other person can now continue with his part of the thing. Much like Mayank did his work, then he communicated to me that okay, I've pushed the code, now you have to go on. So that was a signal he emitted, and which I was connected to. I observed the signal and acted upon it. And okay, so the basic button signals can be used from node. Texture button signals. So I think it's toggled which we'll be using. Let me check. Yes, toggled. We'll be using toggled. So toggled. We'll use this toggled and we'll connect it to our Node 2D's script. So I'll press connect, and this is the code which is just once again toggling the state of our audio stream player and saving that data in game state.music. So let me just copy the same thing in here. I've explained just two lines of code, that it's nothing. And remove this. We don't need it anymore. Now I think our muting should work nicely. Muted, unmuted, muted. So it's working. It's working. Nice. So we have done muting things. And yes, there's something I have to add in here. Saving feature, which we'll be implementing in some time. Stay tuned. Game state dot save game. I'll define this function there. I will. Okay, we did it. So this pretty much does it for our mute button. Now we'll add the stats button, which will show the high score and the credits. So let's add it. So first create another node like we always do. Node.2d. And let's see the scene tree, how I did it there. I had a node 2D. Then I had another node which was showing these things. Okay, so this node controls whether our start screen would be showing or not, and this node controls the button too. So I have a node which has two children, a node and a button, and that second node has all the stat screen with it. The stat screen has a texture rectangle, much like a sprite, but can be used for backgrounds. Then we have four labels like what is the high score number, then the credits, and instead of four we could have just used three labels, but okay, I'll be using three labels. So let's do it. Node 2D, and then I'll add another node 2D again. Then I will add a texture button added, and this texture button, it will have two textures. The information texture, I'll be loading it. It's in the assets folder. Extras, I have the info unpressed.png. It's too big. Info unpressed.png. I have to change it to 1/20th of its size if I remember correctly. Yes, I think that is it. 0.05. 0.05. And the position was 900 and 490. Again, it was maths. I won't do it again. It will just add to the length of this stream. You can do it yourself. 500 because who cares? No, 490. It looks a bit off. Now they look aligned. The mute button and the info button. Yes, it's okay. And was there any toggle state? Why would I have implemented a toggle state? Yes, I implemented a toggle state because I have to toggle the start screen visibility, if it's visible or not. Okay, so that's pretty much about. We'll do the same thing with this. We'll add a signal to the node 2D thing, and then we'll have a script running there which will just change the visibility of our stat screen. So let me add a texture rect, as we were talking about. A texture rect, it is just for showing a texture, a rectangle which shows a texture. Let me add a texture to it. Load assets. Background had it? No, background didn't have it. Yes, the texture. Load assets, extras, panel no dots. This would be a background texture. And for the size, position would be 256 as far as I remember. 256 centers it, and I gave it some. Was it this big? I think it was half of its size. No, it was this big. Check the texture 256 and Y50. Okay, Y50 was just a trial and error of whether it looks good or not. Okay, we have texture rect. Now we will have some labels. Let's add those labels. Labels are just text boxes. So label again, we'll be loading a we say we'll be loading a font, a true type font. This time we'll be using Monster. I don't remember the full name. It's something Monster. It's the same font used as in Undertale. And I'm not using this project for any commercial benefits. So I hope Toby Fox doesn't sue me for this. And alignment should be center. Alignment should be center. And theme. Let me add the font just like I did last time. For font should be a dynamic font. Add the dynamic font. Font data, which is in extras, it's called monster friend back. Open it. Okay, I think you might be able to see high score written over there. Let me give it a spacing. What spacing did I give it there? Give it the same. uh, Theme settings, size 32. settings size 32, double of what was there initially. And yeah, 32 half is 16. No, I will have to see that from the label itself. Doing it wrong. Rect. The size says 278. So what we'll do is 512 minus 278 by 2. Let's see what the thing was. Or I can do it 139. I have to subtract 139. So it should be 370 to 3. 373, I guess, would center it. It centers it. And y 100. 150. No. 150. 120. See what was there. I can't do trial and error oddly wrong. Um, 150, 150, 150, 150 high score. Then we have another label, which is the child of Node 2D itself. And no, why don't we just copy it? We just have to change the, what do you say, y coordinate and the size. So I'll just copy it from there to save time. Y coordinate is 200, size is, I guess, 50. So y coordinate should be 200. Size I will change from themes. 50. Oh, what did I do wrong? Oh, it's using the same theme. So I'll add an override for this label, which will override just this node, not the prior node which it shares the theme from. So I'll use theme overrides, and in fonts, constants, colors, I think there's no option for the font size in overrides. Let's define a new override font itself, which will be using the same font data as monster. Shoulder pain. Open settings. It shouldn't be 60. It should be 50, my friend. And again, we'll have to do a bit of math. 217.5 should be subtracted from 512. I have a lot of things going in my head right now, and I'll just use a position 256. 256. You sure? Because I said the size is 512 to avoid headache. Nice, because I have already center aligned the thing. Nice, I'm smart. And yeah, change it to 0. We'll connect it to GameState.gd's high score variable. Let me define a high score variable too, because high score is something which should be a game's state and should be persisted from gameplay to gameplay. So I have to add it in the game state. So let's make a high score variable. What am I doing? High score is equal to 0. Okay, because I have to set something later in the logic. I'll define how to fetch the high score and things. Is there any update from my friends? Okay, skip to main. Should I copy it again? No, I have one thing copied already. So yeah, this time I'll be writing the other things, credits mainly. So let's use the same font. I won't change the header. You can change the header yourself. Okay, let's make 4 labels. Tiring work. Label 3, Y300. Simple. Label 3, Y300. Where's the right? Y should be set to 300. And the text should be credits. And then I have another label for which I will use a theme override. A font which would be okay. I think my video overlay would be here, so you might not be able to see what font overrides are. Let me show it to you again. font data. I'm just using a new dynamic font here and loading, say, the monster friend. And in settings, I think the size was 16 or 20. Oh shit, has to be 20, my friend. 20. Okay, I guess this was it. Yep. Let me just be confident with things. And here it was, Mayank. Just let me first give it a Y. So 350, I guess. 350 works fine. Let me give Mayank some credit and myself some credit. And then music by Toby Fox. And all the assets are taken from itch.io. Nice. I've given credits. Think that's fine. This is a fine amount of crediting done. Mm, hmm. Now, why did I have two scripts? Okay, one script was to control the visibility of this overlay, and the other script was to change the high score text which will be fetching from game state. We'll write that code later. First we'll write the code for changing the overlay visibility. Okay, so I'll show you what it looked like in the original game. Very okay, what's the second script for then? It's doing the same thing. Why do I have two scripts? I don't need two scripts. I need only one script. I can just remove this script. I don't know why I have this script. So okay, so what the script will be doing? Node when the node is loaded onto the scene tree, its visibility would be false. And when I'll toggle the texture button, which will be a signal from this texture button, which we have added to our node there, it will fetch the high score from game state, and our visibility would be toggled. So very easy code. There's nothing into this. Just copy this. No, I won't copy this. I'll write this myself. It's such small code. Um, it should be stats.gd. Nope. Stats.gd. Create. So, ready. Dollar. Node 2D. So what is dollar node 2D? It dollar just signifies that we are giving a path to a node. So right now we have a child node 2D. So we gave a path to our child node 2D. The parent is node 2D too, and the child is node 2D. So we'll just set its visibility, visible property visibility to false when the game loads. Okay. So when we'll play this, like right now, it's visible. When I'll play the scene, boom, it's not visible, right? So yeah, now we'll add something like we'll ask this button to emit a signal to toggle that stat screen. So let me do it for you. Texture button. Again, we'll just emitting a signal toggled. We'll add it to our node 2D script. Done. And then we'll ask it that dollar node 2D label 2, which is our high score, is equal dot text. The text property of this node should be equal to string of a certain game state.gd high score variable. Have I defined the high score variable? Yes, I have defined the high score variable game state dot high score. So it will show us the high score. If I change the high score a bit, because what I said in the text was 0, if I change the high score so that I can show you how game states work, like let's say the high score is 5 now, do whatever you want. Okay, so it will show 5 now because I've set it in the game state. Now, the dollar node 2d dot visible is inverse of dollar node 2d dot visible 2d dot visible. I guess this does it. This should work now. Let's see. Oh, it works, and high scores 5 now. So, yep. Our game states. Wait a minute. I haven't given another texture to this button. I forgot to give two textures to this button. There should be a normal texture, then there should be a press texture too, which is there in extras. Infopress.png. Open it. I think it should work now. Go. So now the button's getting clicked too. At the start it was not getting clicked because I missed giving another texture. So yep, now what is left is the start button, which will take us to Mayank's gameplay screen. So let me just for once remove this. Now what our original game looks like. We have a big fat start button just below our flying bird there. We'll add it and we'll write some code to like uh, redirect to that scene which Mayank has created. Let's do it. Hmm. What was the scene tree there? Just a simple texture button? Yes, a simple texture button, nothing else. Why have I added this player? For some reason I added the player. I think I don't need the player here. That was Mayank doing some things. Hmm. Texture button. So this is a start button. Let's give it a texture. Load a texture, friend. Play unpressed as a normal state, and we'll give it the scale of 0.1, 1/10 of its original size. So that's about the size we saw on that screen. And then load extras. There's no play pressed. We forgot uploading play pressed. Okay, okay, do with this. I think I have it on my local system, but it doesn't matter a lot. Let me just change the position. Size is 204.8 now, so 102.4 should be subtracted from 512, which makes it 410.8. I think I got my math wrong. I think I got my math wrong. I have a lot of things going on right now regarding the game. I just did 409. It should be 409.8. It looks better now. Why? I think I did some hit and try. 400. Go boom. 400 works. I think I used 350 back there. Use 350 back there? 384. Why did I use 384? Oh, that's 3/4 of the screen. Never mind, I'll use 350. So a simple script attached which will just take us to world.scene. If I know, am I working on world? To world.scene. So let me load that script up there. I think we have pretty much. This is the only script left. Which connection is it making? Where is it connecting? To Parallax Background. Oh, to Parallax Background. I commented some code at the start, and we'll be using that. And if I could just import unpressed button, I'll just try to import that too. Wait a minute. I think I can import that. Modern purple UI. No, it was pixel buttons too. No, 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 no. A folder, not a zip file. Pixel buttons 2 rock buttons, pixel buttons 2, and it was play dot pressed. Play pressed. I got play pressed. Let me just import it. Importing is pretty easy. Drag and drop. Done. Let me do it now. So I had this pressed texture missing. I'll just load the pressed texture now. Nauseating. I'll just give it a pressed signal to our parallax background script, connected there on texture button pressed. So this was the code which we commented. We'll use it. Control C, change C to world.tscn. It will just take it to Mayank's scene which he created, and we'll remove these comments out now. We don't need them anymore. So get tree, what get tree does, get us the scene tree. uh, get us the scene tree of the scene with all the nodes connected in a tree, and it would change the scene to some other scene. This is the generic statement we use for changing scenes. Now, I think it should work. It should work. Am I missing? I don't think I'm missing some. And one more thing, I think I should create the start.tscn as the main scene. So instead, I'll just play this from here. Plays. I don't need the music right now. Uh, oh no, the button shows on top. Button shows on top because it's at the bottom of the hierarchy. I have to move it up. Now I don't think it will show on top because the layers are defined from how lower your node is in the scene tree. Seeds now not coming below the start button. If I press the start button, moment of truth, it works. I'm into Mayank's scene. Now what I have to do in a scene is to add some music to it, add a background, add a scoring and depth feature to this scene. That will take some time. Let's do this. And yes, he is not implementing deaths. It is basically just moving. Let's make his game spicier. Let's go to world.tscn. And how did I change world.tscn? I added a sprite to it. Let me see here. I made a parallax background, but it's not really needed now. I only need two sprites. Parallax background was for if I added two more layers or something like that, but I don't think it's needed now. Or I can just do it for you to expand upon things. Right now, I will avoid the parallax background. I'll just add two sprites to it. So let me create a node and add two sprites. Why I'm adding two sprites? Because one sprite, when scaled twice, appears a bit too much stretched out, and the resolution's not good. So and the sprites are like mirrored, so you can just place two sprites next to each other and it would look like a very uniform picture. So I thought of going by that way. I think that's a much better way of doing things. So add a node again. We are doing the same things again and again. Then we'll add a sprite, not an animated sprite, simple sprite. Another sprite to this node 2D. Now we'll give it a texture. Assets. It was in the background. Yep, background 5.png. Nice. I have to change the Y scale by a little bit, and the position has to be minus 256, I guess. X minus 2. No. Minus 128. Yes, because minus 128 because this is 256. Works. And sprite 2 again. 512. So that's how I calculated it. It's again basic 2D geometry. I did the math beforehand so that I don't waste time here doing math. Y 1.2 and the position should be 128. Yep. Now see, it looks quite uniform. So it gives us the illusion that this is one single picture. If I would have stretched it, it would have played with resolutions and it would have looked bad, ugly. Now it does not look ugly objectively. If we play the scene, okay, let me play the whole game for. I'm doing it. Yes, I did it wrong because the node should be at the top here. That's why the pipes and bird was not showing up. Again, I mixed up with that Z index thing. So now our gameplay scene has a background, a good looking background. But now we need a HUD. What's a HUD? A heads up display. Shortened is HUD, a HUD. And a HUD is basically the score meter which will show on top. So let me make a score meter for this game. I think the score meter should look on top of everything else, so it will come at the end of the scene tree. Add a node to the root node. Again, we are adding a node. We'll add two children to it. One of it would be score, one of it would be a label score, and the other would be the actual numeric label. So we are just doing things, moving in circles here. Label, label, label again. Call it score. We'll change the font in a minute. We have already done that thing. Another label that would be score. This would be 0. Let's add a theme to it. Theme, new theme, dynamic font. What the font looks like? It would be cave, our monster thingy. Monster thingy sounds wrong. Monster friend back. Open settings. What settings did I give it? Such pain. Sprite to what? Acha. Theme. Show me the settings. Size 20. Alignment should be center, which I have not done there. I'll do it in a minute. Center align it. Alignment should be center. And the direction. Right. Now the size is 100. So I'll give it a position of -50. Tada! It's centered. Now I have to give it a position of what? -200. -200 is too much. -100. -150. What did I do there? Why am I doing this again and again? I should just see values from there and input it. -145. Wow. I was close. -145. Label 2 has to have the same themes. New theme. Dynamic font data, load, assets, extras, master brand, repetitive. Settings, font size. What's your size? 32. Double like was the original one, and yes, this has to be center aligned as well. Center. Now rect 40, so I'll give it a position of -20, but I have to I must increase the size X, because as we will have more digits it will take more size, and then the positioning will be different. So I should give it a larger area. -250, I think that does it. And we had 145 there. I think we have 120 -120 now. -120 looks good. Did I actually strike the value which I had then? What was the correct value? -120. That's why it looks good. So now we have a score meter tool. Let's check this scene. It looks good. The score meter is showing on top of the pipe and on top of the bird too. just like in Mario. If you have ever been to the top of Super Mario Bros, you can actually see the Mario sprite going behind the stats side of the stats HUD of the game. And that is one thing that speedrunners and some glitch finders do. And do we need some music to our scene? Hell yes, we do. So we'll add some music to this scene now, and now we'll be adding Megalovania. Megalovania is one of my favorite tracks because it's the final boss Sant, which our guy has to go against in Undertale, and one of my favorite tracks is Megalovania. Let me add it. Audio stream player. Add it directly to the root of the screen. Audio stream player. Audio stream player. Add to it. Megalovania is an extras. Megalovania. Let's play it. Place. Okay. So autoplay has to be on. Yes, it has to be on. And we'll be adding a similar thing as to what we did in our start screen with Death by Glamour, the same script, similar script, not the same script. Here in there's no way to toggle the mute button because we won't be adding a pause button to our game. That is a task we impose upon you. Like if you want to do changes to this game, first thing you can do is add a pause button, which we won't be adding deliberately because we want you guys to learn something and implement it too. So add a pause button to this game after this session ends and do some digging, read the docs of Godot, add a pause button. I don't know how, add it. Like you can. I'm doing a lot of things. You might have learned something from it, and you might be able to add a pause button. The game, the music plays. Let me start this. And if we go this way, first it's Death by Glamour. Then when I switch here, Megalovania. Nice. That's what I wanted because autoplay is on. Did I leave autoplay on there, or was I complete like handling autoplay with scripts? Let me check. No, autoplay was on there too, right? And what script was I using to handle it? Hmm. Okay, so this is something on death and funk ready. It has to play. It's very basic script. I'll write it myself. So I had a script. Game. Let's name it sfx.gd. It's not technically sfx, but who cares? Huh. Self.play. This will just play the game on start, play the music on start, because self is that audio stream player itself. It will play the music on start, and we'll pause it if game state.mute is true or not. So am I using mute as is playing? I'm using music, not mute. So that is something like is playing. If game state.music is false, music is false, just pause this. Self stream paused. It's equal to true. Simple. Else it. So let's just go with things. It's playing. Start it from start. Okay. Right now it's playing, and if I go to the gameplay scene, it plays the music. Now when I will mute it on the start screen, I mute it on start screen, and if I go to gameplay scene, it doesn't play the music. It's the functionality I wanted, and it's working fine. Nice. So I have implemented music right now. Good. We have done music. Now what else do we have to do? Oh, one thing remains for the UI part of the gameplay scene, and that is uh, the overlay which you get on death. Whether you want to go back to the start screen or you want to replay, like do another playthrough of the game. So you can see the scene tree, how I made it there. Show me the node tree. So yep. So if we scored a high score, it will show high score, else it would show oh no. And that was controlled using a script. I'll show you the script later. So, but what we are doing here is, again, we have a rectangle, texture rect. In that we have a label, a single label, and we have done some smart work here. Like, this is not smart work, this is lame work, but okay. We have positioned the texture rect in a way such that we can see the original score, the original HUD also. So we don't need to show the score again into texture rect. So we just need to show whether we have created a high score or not, and that can be done using one label. And we can pass the string in the signal itself, which I'll be telling you later how to do it. And then we will just be adding two buttons. One button will just restart the scene, the other button will load the start screen again. So let's do it. Another node, time for another node. So many nodes. Add a texture rect. Sounds like tesseract. Texture rect. Texture rect's children are label, texture button, and this is something like our stat overlay, because it would be there but be hidden and will show up once the player dies. And we'll do that using death signals, which I'll be implementing in a short time. Frame and label, we need a label, and I will call this oh no, because you were not able to create a high score, I'm so sorry. Two buttons, texture button. Again, we are using texture buttons here because we have got the assets to put on buttons. We don't need vanilla buttons here, so we'll use texture buttons which are provided to us by Godot. So texture rect has to have a texture. What texture we'll be using? Panel no dots. Extras, you got panel no dots. Open it. Now I think here we have to change the scale a bit. We halved it. I halved it, not we. But I'm using we because we are all seeing this stream, being a part of this. It's 512, so I'll be changing the position to minus 256, 128. The y has to be minus 128. No, it has to be 100. I think even half was a bit too much. What was the scale I did here? 0.4, 0.4, and I did some math here then. Okay, I'll just copy the values. Was this? This was what I did. Minus 80. That makes up for death overlay. The label now. Now again I have to give it a theme. The same thing again and again. Running in circles. That song from by Post Malone. Circles. Ah, acha. I have to give a dynamic font first. What happened? Jaldi kar. What was the size? Should keep track of these things. What was the size? 40. A line should be center. I have to increase the size because it has to contain both high score and ono. So size should be like 500. Looks good. Or I will just use the values which I did it earlier. think that's more optimal. Rect size was 512. Nice, nice. 512 position was 100. Okay. Position was 100. Oh no, no, that makes it. Texture button again. I will have to make them 1/20th of their size. Such a pain. Normal. Now we'll be using this button for our returning back to start screen. So I'll have to add the button of cross unpressed for the normal state. What was the scale? These rect values, zero point zero 0.08, not even point 0. Okay, why do I care? That's why you should make a game first and then make it again on stream. Helps a lot. No button masking needed. We need a pressed state too. Cross pressed. Open. Yep, I guess it's good. We are cool. We are good. 48.16 and 300. 48.16. How did I even reach this figure? Through math. I won't worry about it. 300. Something similar to this. Add textures like the play button again. We'll be using the play button texture. Play unpressed. Open. Speed running a game making session. What was there? Another rect. 300, 300, 0.08, 0.08. This was pretty straightforward. Rect, rect, rect. Get rect. Get the rect property of this node. 0.08. 0.08. Now we have got our depth overlay done. So for now, I'll just write the script to either restart the gameplay scene or go back to the start screen when the player dies. But I won't be able to show it to you right now because I have not implemented the death of our player. Our bird's not dying exactly. So I would have to do that too. But because doing this reloading scene and going back to the start screen is easier, I would do that first. That's simply 2 lines of code. Let me first show you what the original script looked like. Yeah. Haha. So right now we won't be worrying ourselves with death. We'll be worrying ourselves with if it's visible on a start and which buttons pressed and what to do when a button's pressed. So again, this is a very short script. There's very less programming skills needed for this session, I guess. I'm realizing that now. So we'll do that again. Death overlay .gd. GD script is something endemic to Godot. So if you learn GD script, you have just learned a skill for Godot, but still it makes making games very easy. So self dot visible is equal to false, because when the game starts we don't want the death counter to come up. So, okay, you have died, you didn't even start the game but you died, I'm sorry, this is impossible, flap flap. But no, we are not making impossible Flappy Bird, we are making a playable Flappy Bird. So we'll not kill the player at the first instance. So when it starts the scene, visibility would be off for this, and then I have to add the signal functions This is the go back to my start screen function. Add it to texture rect, and we get tree get node, I guess. That was the function, that's the thing we do. Dot get the scene tree, then from that get scene. Get scene, is it get scene or something else? It's change scene, not get scene. It's get node and change scene to start.tscn. That's done. Now for texture button 2, we'll just reload it. Connect it to texture rect Wally script, and get it was a different line, I guess. Get reload current scene. Okay, get tree dot reload current scene. This does it, but I won't be able to show how this works, or maybe I can if I comment this out. Now it would be visible even at the start, so I can interact with this. Now when I will press this button, I go back to my start screen, and when I press this, it will just reload the scene for me again and again, and I press this, I go back. So I could also show you the testing one, but we should set the self visible dot false, because when I want to start the screen, I don't want my bird to die, so it's not dead yet. And now comes the important part, and that is scoring. So let's do some scoring. Let's score some stuff, because the UI is done. The UI is pretty much done. Now what we'll be doing is, okay, I must write the save functions too. First I'll write the save functions, then I'll do the scoring thing, then I'll do the death thing, and the game would be complete. So let me first show you how to save a game. So gamestate.gd, we will be doing our save game things there. Now this is a bit this is something you must pay attention to. Function save, what this function save does is, it first creates a dictionary which saves the music of our music variable of our game state by the index music, and high score variable of our game state as by the index of high score. This is the JSON notation. If you guys are familiar with a JSON notation, JavaScript object notation, and it has got nothing to do with JavaScript. It just looks like a JavaScript object. That's why it's named JSON, JavaScript object notation. This is pretty much the notation which Lua uses for tables, and Python uses for dictionaries, and GDScript uses for dictionaries, because GDScript is a lot similar to Python. So yes, we are just creating stringifying it into JSON. So this is our save function, which will return a dictionary. What we do is, we'll open a new file, and we'll name it savegame.save. We'll open it in write mode. Now if you guys are familiar with Python, we have an open function there too, where we have to specify a file object, then assign it a name, and then we have to give it in which mode it's opening, whether it's opening it in write mode or read bytes mode, whatever. There are many modes, you can read it in Python documentation. And then we have the node data, which calls our save function, so it will return the dictionary as node data, and we will convert the node data to a JSON string. I explain what JSON string is. What a JSON string is, it is basically a string format, and we'll use save data.store line, which is similar to the write lines function of Python, which basically just writes lines to a text document. So we are just writing lines of a JSON string to a file, and then we'll save it. We are saving it in user folder. You can check out the Godot documentation to know where exactly the user folder is. On your OS, it's different for Windows, Mac, and Linux. For Windows, it's somewhere in the app data roaming of your PC. So you can check there would be a Godot folder in which there would be a project name folder, and there would be a save game.save, or there would be user files folder. That is the files. You can explore it. You can check the documentations and explore it yourself. Then we have this load game function, which basically just opens the file. If the file exists, it will read it, and it will parse the JSON. Parsing is something like reading the statement and then execute, like knowing what it does, acknowledging what it does, and it will parse the JSON from a string to a dictionary. So we get a dictionary, and then from that dictionary we'll take the index and we'll assign the what to say variable. So how will this help us? Suppose today you played this game, you made a high score of 120. So what this save game function will do, it will save whether you muted your music or not and what was your high score into a save game.save. Then when you will open the game next time, it will load that data from that save file and assign music and high score variable the values which was written into that save game.save file. That's how game saving works, and it is an important thing to save data stats like high score, how many times you died. We are not implementing how many times you died. We are leaving it upon you to do. As we said, we'll be doing some deliberate, we'll be having some deliberate pitfalls for you to cover. And yes, so I've explained the code. I think I can just copy it into my mind. So let me just do it. Copy it. Why give it? Who cares? And you might have observed I removed some save game and load game statements from some places. So I have to add it there, like on BG scroll. It was not BG scroll. Muting.gd. Game state load game, because we want to load whether the game is muted or not. So we'll call this function, and whenever we mute a game, we'll save the file so that the change can persist. So whenever you press the mute button, a file would be saved there, which will save whether the music has to be muted or not. Whenever you start the game, a file would be loaded. That save file would be loaded to check whether you're to update the high score first of all, and whether your game is muted or not. It will set the variable in game state, which this script is fetching through game state.music. So that's how things will work. I think it should work now. Did I do any other change? Okay, you removed game over and lamau.dead. Okay, I'll be doing that in a minute. Stats. Did I do anything else? Stats is something which would be loaded. I guess that's all. The only thing where we have to use save game, and we have to use it whenever we set a high score to. I'll be adding that feature in a minute. But first, okay, it works. I think the saving feature will work now. Because I've muted the game. You notice that when I started the game, the music was playing, then I muted it. So technically, that mute information should have been stored in the save game file. Now, if I restart it, it would load that save game file and check the state of whether the music was muted or not, and would set the would mute the stream accordingly, because I have written that logic in here. Game state dot will call load game, and game state load game function will set that music variable, which is being used again by player.gd, muting.gd here in music. So things must work as I expect them to. Let's see. The game's muted. The music's muted. So our saving game is working flawlessly. So we can now proceed with actual scoring and death. So let's do it. So how I implemented scoring, let's check the script. This is the last part, guys. This is the final part. It will, I guess, take 15 to 20 minutes more, and then we'll be done with things. Then we'll go to eat and sleep. I define two signals. Now, signals are not only implemented using the Godot engine itself. You can define signals in the script, connect them manually using code in script for custom signals, because you won't be getting scored or death signal inbuilt from Godot. Like Godot doesn't know that you have to make a Flappy Bird game every time you open Godot. No, you don't do that. So for custom signals, we have to write the code ourselves, which I've done here. So how did we on detect area entered, the score will this is what we have to do. On detect body entered, if body name is wall, I'll call a function called lamout dead. The bird's dead now, and what dead does is it will set the wall speed vector to 0, gravity to 0, flap to 0, motion to 0. Oh nice. And if score is more than game state dot high score, it will emit the signal of death with high score as a string. In the death overlay we had a string which was showing oh no. We can change it to show high score or oh no, depending on whether you made a high score or not. So if it passes a high score, it will show a high score. If you haven't scored more than your current high score, oh no, sorry. So and if you have scored more, you will have the high score set as your current score, and then it will call the save game again. Nice. That's some good logic. And yeah, the game state wall speed. Why am I implementing wall speed in the game state? I'll tell in a minute. Because signals don't travel inter scene. Like you can't make a signal go from one scene to another if that scene is not a child of this scene, which we haven't done. So you might have like observed there is this is the wall node which has a script attached to it, which makes the wall. Okay, in our project, sorry, in our project, wall node which has a script attached to it which makes the walls go somewhere. Okay, so when we have to stop the wall node scene is different from our world.scene where the actual gameplay takes place, where we are calling all the signals. And if we call the death signal there, how will it reach this scene? So instead of handling it through signals, I stopped the walls by making the wall speed vector a game state variable. I'll be doing that in a short amount of time after we implement scoring, because maybe I've given out a lot of things without writing some actual code. I've explained a lot of logic without showing you the code. So let's write the code first. So player.gd has to have a lamouded and an emit signals code score. So first we'll create a signal. Player.gd, let's create a signal. We have a variable score here. I like it. And we will also have a signal called death with a value, and that value is a string, high score or oh no. Okay. Okay. On detector body entered area, if body dot name is equal to wall, and what was his wall node? Let me check. We had that. We have this wall node. Collision shape, which we need this collision shape's name. Is it called point area? It should have been called point area. It should have been called, what did he name it here? I have to rename this, or instead I'll just use area 2D. I'll explain what I'm doing, but right now I'll have to write some code. Player.gd. If body.name is equal to let me lamouded, and let me declare the function before. Okay, Godot gave me an error. Sorry, Godot. Now I have to find the function. I have to find. Oh, sorry. Find a placeholder to the function. I think this passes. Lamounted function. We have given a bare bones of this function. It works. No, sorry. It works now. No more errors. I'll define Lamaudet in a minute. And incrementing of score. Okay. So I have to do this. If body dot name body, if body dot name, the name property of this word body is equal to area 2D, because you see in our wall node this thing is area.2d. What is this collision shape? This collision shape is the let me show it to you guys so that it's more prominent. You can see the rectangle. Like if I select this is the lower pipe, this is the upper pipe, and this is the space in between those pipes. And if our player's collider collides with area 2d's collider, it means that the player was able to pass between the pipes, and I being the rightfully I should increase the score of the player. So I'm detecting whether the player's collider entered the collider between the pipes. That's what I was doing on in that script. Oh, sorry. That's what I was doing in that script. On detector area entered. So detector is if I show you the world Zavarudo, and detector was an area 2D which had a collision shape. If it enters one of those colliders between the pipes, the score must increment. So I will increment your score. Thou shall be rewarded. If body.name area 2D, please increment the score. He did a good work. Score plus is equal to 1, because this is much like Python, and Python doesn't have that increment operator plus plus which you use in Java and it is an area. I'm sorry, not a body, area. Java and C++. So score plus 1, and I have to emit signal scored. Scored along with its score attribute, which I would have done here too. Let me check if I did a similar thing here. Yes, I incremented the score if the area name was point A, because here it's named point area, there it was named area 2D. That's why I called area 2D. I did score plus is equal to 1 and emit signal scored. You scored a point, congratulations. So, and I passed the score which you have to show on your score counter. So let me go to the score. Where's my this is my mouse pointer. I've emitted a signal scored. Now I have to go to those labels. No, this is Zawarulo, the word. I did no changes. Why it was showing as if I did changes? Where's the score thing? Where are my two labels? No 2D2 labels. These are the labels. Nice. I have to add a script here. Create. Now in the ready function, I would add a connection to that signal scored, and that should work. I would add a connection. So what will happen whenever it would emit a signal scored, this one would be on its guard to check if a signal scored comes or not. It heard scored. Oh, he scored a signal, so I must do something related to it. What should I do? I'll write the logic. I'll show you the logic first, which we wrote in our original game, which was Zavarudo. Jojo references a score label. So function on scored value, score.text is equal to string of value. Wow. So how do we do the connection? We get the parent. In this case, the parent is the score label, and then we will get the node. And in this case, the parent is the root. We'll get the node, which is a player kinematic body 2D. I will see what the path there is and add it. So basically, we are getting the node which will emit the signal. In this case, it was kinematic body 2D, because if we go to kinematic body 2D player slash kinematic body 2D's script, it is the one which is emitting the signal scored here. Okay, so I connect the signal scored to myself, and the function connected is called onScored, and onScored will change the child scores text value to the value which will be passed by the signal. Because the signal is passing a value, in this case we'll have to convert it to a string first, obviously, because this is like Python. So let me do similar things there. Func ready. Shit. Func ready. Okay, so here the path would be a bit different, because there have been some changes to naming done by Mayank. So we'll take care of that. But get node player node slash player is the kinematic body. That running man you are seeing there is the icon for a kinematic body. So player node slash player. So we got the player node. We are attaching a connect function to it. No, the signal is not that. It's called scored, and it will be connected to self. The body is node 2D2, which handles two labels, self, and the function it's connected to is called onScored. I think that's okay. Yes, that's okay. And now I'll be writing the function onScored, what onScored has to do. And after I write this small piece of code, I think the scoring should work just fine. Let me see what the child's value is. It's called label2. So label2, because you see label2 is the thing that will display the score. So label2.text would be equal to the stringified version of the parameter onScored passes to us, the signal scored passes to us. Now when I play the game, it should show me the actual scoring I'm doing. So let's do it. Score 0, moment of truth, it works. See, now you can actually increment the score while playing, but you can still not die. You cannot die. You are in God mode. You are in God mode now, and that is the fun of game development. You can do things to the game in development which you cannot do to the production version of that game. I once played a chess game which was so screwed that it was like 10D chess. We were making it on 3JS. It was a nice experience, harrowing experience. So yes, the scoring works. Now on to death, the universal truth. Death, player GD. I have the signal death, and I have a function lamao dead. Now what does lamao dead do? It will first check if your score is more than game state.high score. High score. It will emit the signal death along with high score string. Yay, you scored a high score. Okay, then what it will do is set the game state variable of high score equal to the current score. So it updates the current high score, and it saves the game because you need to save the new high score value so that it persists in the next game. So save the game, game state dot save func, save game function. Nice. And else, I'm sorry, you weren't able to score a high score. So I'll just emit a signal with your death. And oh no, I'm so sorry. What happened? Indeed, I don't know what's happening. Death has got implemented right now. So now, when you die, what all things happen? First is that every motion should cease. Yep, every motion should cease. So I will set the value of gravity to 0 because you don't want the bird to fall. You want it to be fixated at its place. I'll change the value of flap to 0 too, because technically I'm still taking spacebar inputs. I have not stopped taking the spacebar inputs after dying. So there would be spacebar inputs, but since the bird has got no speed, it won't go up or down. It's like the bird's trying to move up, but it can't because the speed 0, the flap speed 0. So Lamau dead. So gravity has to be 0, flap has to be 0, and you will now note something very interesting. Let me show you guys. There's a bug. There's a good bug in this scene. See, even after I had set even after I had set the gravity and flap as 0, when I died, it didn't go down but instead got up. Why is that so? Because of a function called move and slide. Now this does some interpolation and actually gives a vector motion in the up direction, and motion like when it died I had my spacebar pressed, so some amount of flap was like saved in that motion vector, which gave it that movement. So what should I do? I should set this motion vector to 0 2 when I die. This was a bug which came when I was developing yesterday, because you see we have a game ready beforehand so that we don't have to worry about math. So it was vector to 0 comma 0, and now when I will play the game it will stop dead in its tracks. Dead. Oh, sorry. Yes, the game's not responsive. There's one more time. This is deliberately done. You have to make the game responsive, or you can just fix the viewport. Just set the viewport as fixed so that I can't resize it. One more thing you noticed is the walls didn't cease their motion, and the walls in our another scene, the wall node scene. I had brought up this problem in front of you guys some while ago, a little while ago, and I think now's the time to act upon it. Yes. So I'll open the wall node scene here. This has been hard coded, like position has to go motion, more position has to be vector 2 minus 20 in a physics process. Physics process works at 60 fps. Process, the frame rendering of process can be different, but for physics process, it's fixed at 60 fps. And so delta is your 16.66 milliseconds. It's fixed. So after every 16.66 milliseconds, the position of the wall node would change by 2x units. This is hard coded, but when you die, I want the walls to stop. So, and signals can't be read in another scene. So instead, I'll define the speed in the game state. I will give a variable. Wait a minute. Um, var wall speed. I think that was the variable he had. In wall.gd minus 2.0. So instead I'll replace it with wall speed. Okay, so I have this fixed in the wall speed thing, and in the player again, whenever we load the game, we have to set the wall speed to game state dot wall speed would be, because when we die we'll be setting it to 0, as you might have noticed it by now, but whenever we restart the level we want it to be set again. And here, because people have died, we have to mourn, so we will be setting the wall speed to vector 2.00. Vector 2 is basically a vector. Vector 2 is x and y. Vector 3 would be x, y, and z. Then there's quaternion x, y, z, w, which is out of scope of this um, discussion. Let's see now. Now the walls must stop too. Walls have stopped. Walls have stopped. Now we want the overlay. We want the death overlay. We are just one step away from completing our game. So go to death overlay, and we have to do a connection to that death signal. We will do it just like we did with scored signal, but now the signals, just the signals different. Get node. Get node. How I did it? Wait a minute. 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 Why did I blank out suddenly? Hmm. Player node player. Why is the get node not working? Nice. Acha, it has multiple parents. Death overlay. Oh, yep. I have figured out what's wrong. Texture rect's parent is node 2d3, not 2d, the root node. So I have to add two get parents to get to the root node. My bad. I'm sorry, guys. That's why I blanked out what's happening. I was like, oh, that's not supposed to happen. What was the name? Player node. Player node player. Player node player connect death self on death. This has to be a string too, sorry. And now we'll call our on death function, which has a value which we'll be setting to our label. So what do we have to do here? Self.visible is equal to true. And yes, now this value is whether you scored a high score or not. So we'll just change the label's text to string of value. Validate JSON nahi, value. Moment of truth. I think the game's complete now. I think the game's complete. Yes, we have completed the game. Let's do a run of it. Okay. muted. Now let's play the game. Uh, First of all, I will set a high score more than 5. I couldn't. Oh no, I'm such a noob. Let's restart the game. Let's hope everything's working fine. Oh no, again. What am I doing? Should I have set the high score lesser than 5 for this game? No, no, no. I made the high score. I made the high score. I made the high score. High score. Now, if I go here, the high score is 7. And if I close the game, play it again, and check the high score now, it's 7. It's saving my high score too. Now, one thing I didn't implement. Our game's not complete yet. See, there's one problem. I have not put the positional bounds. What if our bird goes out of the screen? Then it has to die. So let's kill the bird now. Ha ha ha. Lamau dead. Remove this unnecessary comment. Now, if I go, first of all, I should show you without Lamau dead. Like it won't be dead first. It won't die instantly, I guess. See, it hasn't died. It has gone above the screen but hasn't died. Now, when I add this function, it will check if the bird's outside the screen or not. Oh no. Now when I left the screen, it's dead. Our game's complete. Congratulations guys, we made a simple Flappy word clone in Godot. So and how much time did we take? It started at 6:30, 6:40 because you guys were late. And in about 3 hours we created a simple Flappy Bird clone, which looks pretty nifty. Congratulations everyone. So that was how we use a game engine to create a game. Okay, so that was an overview of how to use game engines to create game, and there was pretty simple coding into this. I explained everything I could, and there are some things I want to like tell you guys. We'll be sharing the code. Like okay, I should first push the code. Git status. See, I've done these changes. I should push them onto the, what do we say, the GitHub repository. I won't be doing it on final. I would be doing it on final. Yep, git commit -s, because I sign my commits using GPG signing. Please don't worry about what's GPG signing. For those who couldn't run their git commands on their terminal because you didn't have git installed, I'm sorry, I should have said that as a prerequisite, but don't worry, you can download the code and the assets as a zip folder. For those who have git installed, they can use git command from the git bash terminal or their Windows terminal, or if they're using a Mac terminal, Mac uses Unix environment, so you have to use a Mac terminal, and if you're on Linux, a Linux terminal works well too. So all the terminals can work with git, and this is the final commit, the final nail in the coffin. Okay, I didn't add, sorry, I did too much build up for disappointment. And for some reason Grammarly works in my terminal too. You guys might be seeing it. I don't know why it does so. I have to sign using my GPG key. It's signed. Now I would push it. Origin final. I have to give my SSH password, my private keys password. You denied permission to me. Mayank, you denied permission. Should I change to a new branch or what? I don't understand. Final. Um, don't worry about it, guys. I'll ask mine to give me the required access rights, and then we'll push the code. The link to this repository, to the assets, is on our Discord's announcement channel. You can check it out there, and you will get the Discord links, and like someone would post them there. Our Discord servers join link if you are not there already, so you'll get it from there. So there are some things which we deliberately did wrong or missed out on, so that you guys could do that in our game, like show us how much you have learned. So first things first, a pause button during gameplay, and instead not a button which should be clicked by a, what we say, mouse. Do a keyboard binding like P for pause. Okay, that's much easier because this has to be played using spacebar. Second thing, you can make it responsive. Like, let me show you one thing. As soon as you resize it, boom, it's all skewed up. We don't want it this way. Either fix the viewport so that we can't resize it, or make it responsive, make it adapt to every size. Then another thing, you might have not noticed this because this is a very minute detail. Audio stream player is connected to the master bus. Megalovania is connected to the master bus, and start is also connected to the master bus. So instead of making two scripts to pause the streams differently, I could have just paused the master bus. So that is something you can implement. But I added two scripts because to have the possibility of having a separate pause menu to like pause the game state background music differently. So you can have Megalovania playing while you don't want Death by Glamour playing, or vice versa. That's why I created two scripts, but I didn't implement that, so you can do that. And you can also add sound effects. This was what I added, was just background music. You can add sound effects, so whenever like you score something, you get a ting. Whenever you jump your player, it's a pew pew or some other sound. Whenever it dies, it has a death sound. You can add sound effects too. You can then make two different audio buses, one for background music, one for sound effects, and you can control their volumes, control their mute state, as you might have seen in some Android games or Steam games. And I would like to show you one project which we did, which we are working on in SDS Labs. There we are working on a 3D. We have been working on a 3D game on Godot. Okay, I think Mayank has given me the access rights. But first, I would like to show you Outrun Chase. So I'm streaming. I'm running 3 instances of Godot. I don't know how is my PC not dead yet. Outrun Chase is a 3D game we have been working on from quite some time. You can play this game locally with your friends or on an online server. This is a multiplayer Outrun retrowave themed game where you can complete laps. And if you drift along walls, you drift your spaceships along walls, you get a speed boost, you recharge your weapon too. So it you might liken this to a game called, what was the game's name? What was the game's name? Data Wing. Data Wing is a mobile game which you play, and if you drift along the walls, drift that wing along the walls, it gets a speed boost. So similar mechanic is being used here, but we have weapons too, which you can fire at your friends so that they spiral for some time and can't orient their ships and can't fly, and you can buzz past them at that moment. You can pull these moves, and you have to come first. The death race mode is completing laps. The deathmatch mode is who kills the most in the given time. We have 3 maps, and 4 players can play at a time on a local connection with Ethernet or your local Wi-Fi hotspot, or you can host a server too. I'll just play it solo. In solo, you can only play the Death Race version. We have got Death Race and Death Match. My name's Raiku. This is the game code I would be giving to my friends to connect to my game if they are on a local network. And I'll choose the track Fire Lily because I like this track personally and it's a fast track. Let me play it for you guys. The starting countdown. So this is not yet open sourced, and you guys can't contribute to this project. But open sourced other things like our text, you can contribute to it. Think that's enough. I've played enough of it. And the next thing we have is our own in-house 3D game engine called Rootex. We have been making a game engine, 3D game engine after Rubius, which was a 2D game engine. We moved on to 3D game engines and we're making Rootex. So let me run Rootex, and I don't know how my PC will react to this. Let me run Rootex a build. So, Rootex is a 3D game engine based on the ECS architecture. You can read more about ECS architectures online. With entity component system, and it has a lot of features. Like it's still in development. We are developing a game over it, and it is an open sourced project. You can contribute to it. It has many issues open, so you can pick up on issues, make a PR, pull request if you think you can do that issue. So I'll show you. Um, I will show you one scene which is like a benchmark scene to show how the performance of a game engine is. So I'll stream it because I'm on stream with two Godot instances and Rootex on. So this is the scene. We have a basic viewport. We have the scene tree here, as you have seen in Godot. In Godot, it's on the left side. We have the inspector, which will show us the components connected, just like Godot's inspector, which was on the right side. We have a play toolbar. We have an output port, and my fans have kicked in. My laptop fans have kicked in. So I'm doing a lot of processing work on this. A lot of load on my PC right now. So yeah, that's pretty much it. This was the sponsor scene, which is used for benchmarking game engines, and it looks pretty good in this. So you can try out, like contribute to the Rootex game engine, which is an open source project. Let me turn this off. And because I think Mayank gave me the rights now, let me push the code. No, I still don't have the rights. I'll figure it out, and we will again post it. We'll post the like we'll give a reminder that yo, our code's out there. So go and do some changes to it. Say, Acha, I have to X. Oh, I'm down. Accept it once. I had to accept the request invitation, which I didn't do. Still, it's not working. I don't know what's wrong. Check. Am I on? Mayank Mittal hai, view invitation. I haven't. Accept invitation. Okay, now it would work. Please work now. Please get up. It worked. Now you might have seen that I have another branch here. It was two branches. Now I've got three branches. Final had recent pushes less than a minute ago. I'm just going to make a pull request and merge it myself because I know this works. We have created it and it works. So on the main branch, you can get a final code on the main branch. This has a final code. This has a working game. You can export the game. Oh, sorry, this is GitHub. GitHub me Discord. This is Outrun. Quit it. You can export the game, like project export, make a Windows game for it. Android, we haven't implemented Android controls. You can make a Mac OS game or a Linux game right now, because we haven't done maybe HTML5 too, but we haven't made it for touch devices, so we can't do it. So you can export your game, so it would be converted into an executable file, and then you can play it. So I think that ends the session. Keep in mind, there are additions which you can do to our project, and we'll be making the project public, and the link would be on our Discord. So yeah, you can go check it out there and make a PR if you think you can add something cool to the game. And do register for Global Game Jam, which would be held from 28 to 30 January. It is a global, an international event, a festival for game developers, where we have to develop a game in less than 20, in 48 hours, and there's no formal judging into it. It's just for the fun of creating games. But we would be looking out for good projects, like great games which you guys would make, and we would contact you if we like those games. Contact you personally in DMs or something, Discord DMs. And what else? I think that's pretty much it. Or am I missing something? I've talked to you about for Global Game Jam. You have to just Google GGJ SDS Labs. Then you will be on the Global Game Jam's official website. Go create an account there. Then join the SDS Labs IIT Roorkee site, so that you can jam with us. And then yep, there's no limit on the team size, and create a game, push it, and show the best you can do. You're free to use any game engine, or you can just make it on Pygame, C++, or JavaScript using some libraries. So that's pretty much it. Good night, guys. I hope this was an informative session. You guys liked it, because we worked on it pretty hard for like a day. And yep, I still have to do my dinner, and I think you guys might have to do it too. So I'll beg your pardon now. Good night, guys. Bye. That ends the session. The recording would be available, don't worry, and it stays on Twitch for 2 weeks, and one of us might have recorded this session too. We will upload it. So I'm stopping the stream now. Bye, guys.